Today we are going to start Unit 16, Salts and Neutralization. So in this unit we are going to discuss neutralization reactions in detail, and we are going to study some of the characteristics of neutralization reactions. Then we are going to study the products from neutralization reaction, salts, and also we are going to study how to prepare different kinds of salts. So today's lesson, let's begin a bit revision of neutralization reactions. So neutralization reaction is a reaction between an acid and a base to form salt and water as the only product. Okay, so that's a key word, only product. So in the previous unit, we have learned the general word equation, acid plus base gives you salt plus water. Okay, so the base that we can use for neutralization reactions can be a metal oxide. It can also be metal hydroxide, right? And also ammonia solutions. So here we are going to discuss the two types of neutralization reactions. The first type of neutralization is between acid and alkalines. Okay, so alkaline means the soluble base, and it should form an aqueous solution when it dissolved in water. So here we got an example. That's a reaction between hydrochloric acid and sodium hydroxide. And the product we should get out from this reaction is sodium chloride and also water. Okay, remember to balance the equation and write the state symbol accordingly. Okay, and then to write the ionic equation, we need to first separate the ionic compound, and then we need to cancel out all the spectator ions. So here we got a diagram representing what's happening in this solution. Okay, so before this reaction, we have sodium ion, we have hydroxide ion, and we also have hydrogen ion and chloride ion. After the solution, the hydroxide ion combine with the hydrogen ion and form those water molecules. And for the chloride ion and sodium ion, they remain as mobile ions in the solution, so we call them spectator ions. So they do not change in the reaction. So the ionic equation, which only includes the ions that have been changed in the reaction. Okay, so for this one, it should be the hydrogen ion that react with the hydroxide ion, which give you water molecule. Okay, and remember to write the state symbol. So that's the first type of neutralization reaction. The second type should be a neutralization reaction between acids and insoluble base. Remember, in the previous unit, I have asked you to memorize a solubility table. Okay, so you should remember that group 1 hydroxide are soluble. Okay, and we have calcium hydroxide, which is slightly soluble. And for group 1 oxides, they are soluble, and for calcium oxide, again, it's slightly soluble in water. And also we have barium hydroxide, which is soluble, and barium oxide, which is soluble. Okay, so for the rest of the case, you're gonna see they are all insoluble. Okay, insoluble compounds. So the second type is the acid with insoluble bases. So here we have two examples. The first one, we have the insoluble metal oxide, which is magnesium oxide here. And the second example, we have magnesium hydroxide, okay, which is again is an insoluble compound. So what's going to be the product for the first reaction? Magnesium oxide with sulfuric acid. So the product going to be magnesium sulfate, and then we have water formed. Okay, so this equation is balanced, then we need to write the state symbol accordingly. Okay, and for the ionic equation, okay, remember we can only separate the ionic compound in aqueous state. So for the magnesium oxide, because it is a solid, we should not separate it. Hence, we should only separate sulfuric acid. And you would be able to see that the sulfate ion actually still remain as mobile ion after the reaction. Okay, because magnesium sulfate is soluble, so it would appear as magnesium ion and sulfate ion. Okay, so sulfate ion would cancel out. Sulfate ion is a spectator ion. So for ionic equation, it will remain as the magnesium oxide plus, okay, the hydrogen ion released from sulfate. Remember, each sulfuric acid molecule will release 2 hydrogen ion. It's dibasic, so it should react with 2 hydrogen ion, and then it will give 1 magnesium ion and also water. Okay, and double check the equation is balanced, and then you need to write the state symbol as well. Okay, so that's for the first example. The second example, similarly, we have magnesium sulfate as the products, and also we have water as the product. Okay, so make sure you have balanced this equation, and again, make sure you write the state symbol accordingly. So for this equation, again, magnesium hydroxide is an insoluble compound, so you should not separate it as magnesium ion and hydroxide ion. So your ionic equation should write magnesium hydroxide, and then it will react with the hydrogen ions from sulfuric acid and produce the magnesium ion with water. Remember to copy the state symbol. Okay, so these are the examples for neutralization reactions. Now take a look at the checkpoint question. First, which of the following is not a neutralization reaction? The first one, we have an insoluble metal oxide. It reacts with an acid and produces a salt plus water, so that should be a neutralization reaction. And second example, again, we have an insoluble metal hydroxide react with the hydrogen ion that are released from an acid, and then it will produce the metal cation with water. So you can compare that with our example here. Okay, so that's also a neutralization reaction. So the copper ion is the cation in the salt. So the second one is a neutralization reaction. The third one is an ionic equation for acid with the alkaline. So again, that's a neutralization reaction. And for part D, okay, that's the answer we are looking for. And you can see after the reaction, it form a hydroxide, form a base. Okay, so for neutralization, it should only form salt and water as the only product. So for D is not a neutralization reaction. Number 2, hydrochloric acid is added into sodium carbonate solution. Write down the chemical equations involved. Okay, so we have hydrochloric acid with sodium carbonate. And the product should be the salt that formed, which would be the sodium chloride. And then we have water formed, and then we have carbon dioxide formed. Remember to balance the equation. Okay, we have 2 sodium, and then we need to balance the chlorine. Okay, now we got a balanced equation. And finally, make sure you write the state symbol. We have hydrochloric acid, and we have sodium carbonate solution, so it should be AQ. And sodium chloride formed is a soluble salt, so it should be in aqueous state, water in liquid state, carbon dioxide in gas state. Okay, so is this a neutralization reaction? Explain your answer. So remember, neutralization should only produce salt and water as the only product. But here we have carbon dioxide produced. So that tells you that this reaction is not a neutralization reaction. Okay, so you need to answer first, no, it's not a neutralization reaction. Okay, because neutralization only produce water and salt as a product. So no carbon dioxide should be formed from neutralization. Okay? In the previous unit, we have done an experiment between acid and base. And when we pour alkaline solution into a test tube with acid solution, and after some time when you touch the test tube, you're gonna feel that it gets warmer. That's because the neutralization reaction between an acid and an alkaline is an exothermic reaction. Okay, so exothermic means it releases heat. Okay, the heat energy is generated during the chemical reaction. So for this unit, you just need to remember 1 mole of hydrogen ion react with 1 mole of hydroxide ion, it will release 57 kilojoules of energy. Okay, and then take a look. Remember, in the previous unit, we have learned the strength of acid and alkalines. So when neutralization involves a weak acid, a weak alkaline, or both, the heat energy would be different to the one we mentioned above. Okay, so for strong acid and strong alkaline, the heat energy release is equal to 57 kilojoules. But if we have a weak alkaline involved or a weak acid involved, the heat energy release would be less than 57. Of course, the number gonna be lower when we have weak acid react with weak alkaline. So this is because part of energy is taken in for the ionization of acid molecule or the base molecule. So for weak acid and weak base or weak alkaline, in order for it to ionize and to give out all the or to give the maximum amount of hydrogen ion and hydroxide ion, it needs energy to do it. Okay, so part of the energy is used to ionize all the hydrogen ion and all the hydroxide ion. Hence, the total energy released is less than 57 kilojoules. Let's take a look at the checkpoint question here. Which of the following always occur when an acid is neutralized with an alkaline? First, there is a decrease in pH. So at the beginning, we have an acid And when it neutralized by an alkaline, the pH should increase. So it would, when we use just amount of alkaline to neutralize it, the final pH should be 7. Okay, so for this one, it should be increase, not decrease. Okay, next one is salt is formed. Yes, neutralization give out salt and water. Third one, heat is given now. Yes, for neutralization reaction, they are all exothermic. And fourth, a gas is produced. So remember, neutralization only produces water and salt, so no gas should be produced. So 4 is wrong. So the correct answer should be C. Now let's talk about the product from neutralization reaction. So the definition for salt is that salts are formed from neutralization reaction. They are formed when the ionizable hydrogen ion of an acid are replaced by metal ions or an ammonium ion from a base. Okay, so remember, only the ionizable hydrogen ions will be replaced by the metal ions or an ammonium ion from a base. Okay, and in order to do this unit well, you must memorize this solubility table. It's essential for this unit. So again, you need to revise this table and try to memorize it. Now, after you have memorized the table, please attempt the checkpoint questions. Pause the video here, complete all the examples, and then listen for explanation. Here it lists out some salts. Let's try to work out whether they are soluble or insoluble. First one, barium chloride. Remember, for chloride, we only have silver chloride and lead 2 chloride. They are insoluble salt examples. So for the rest of them, they should all be soluble. Okay, and then next one, potassium carbonate. Remember, all the group 1 salts are soluble, so this one should also be soluble. Next one, silver oxide. For metal oxide, you need to remember only group 1 metal oxide, barium oxide are soluble, calcium oxide are slightly soluble. Okay, so silver oxide must be insoluble. Next one, mercury 2 sulfate. So for mercury 2 sulfate, the sulfate ion, you need to remember 4 special cases. So they are, remember the ABC PEP. Okay, so we have A is silver, B is barium, C is calcium, P is lead. Okay, so only these 4, when it combined with sulfate ion, they are going to be insoluble. So mercury, when it combined with sulfate, it should be soluble. Next one, zinc nitrate. All nitrate salts are soluble, so we just need to put a tick for that. Next one, barium hydroxide. Okay, so for metal hydroxide, you need to remember this special one. Barium hydroxide is a soluble, soluble compound. Next one, barium nitrate. Again, all the nitrate salts are soluble. Next one, lead 2 carbonate. So for carbonate, you need to remember only group 1 carbonate and carbonate with ammonium ion in it are soluble. So the rest of them are insoluble. So lead 2 carbonate should be insoluble. Next one, potassium oxide. Group 1 oxide, they are always soluble. Next one, silver chloride. Again, for chloride, you need to remember 2 special cases. ABC PEP, so the AP at the end, it represents silver and lead. So silver chloride should be insoluble. Next one, zinc sulfate. So for sulfate ion, ABCP, so zinc is not included here, so zinc sulfate should be soluble. The last one, chromium 3 hydroxide. Again, for hydroxide, remember those soluble ones. Okay, group 1 hydroxide, barium hydroxide, and calcium hydroxide, which is slightly soluble. So chromium 3 hydroxide, although you haven't come across that before, you should be able to tell it's insoluble. The last part of this video, we are going to talk about different type of salts. So we have normal salts and acid salt. So what does these two terms mean? Remember, we have learned the basicity of acid before. So for some acid, it can, for example, if we have one molecule of that acid, it can release more than one hydrogen ions. So for those, let's say dibasic acid or tribasic acid, sometimes the ionized hydrogen are not fully replaced by the metal ion. In that case, they form an acid salt. Okay, so take a look at the definition here. So for salts formed by replacing all the hydrogen ion, they are called normal salt. And for salts formed by replacing only part of the ionizable hydrogen ions, they are called acid salt. Okay, it would be more clear if I show you some examples. So here we have sulfuric acid as an example. Remember, sulfuric acid is a dibasic acid. So maximum each sulfuric acid molecule can release 2 hydrogen ions. Right, so the first example, both of the hydrogen ions are replaced by the potassium. So it forms a normal salt. But for the second case, only one ionizable hydrogen ion is replaced by the potassium ion. Hence, the salt we have formed is KHSO4. So in this case, that's an acid salt. So the potassium hydrogen sulfate is an acid salt, and when it dissolves in water, it would form potassium ion and also hydrogen sulfate ion. And the hydrogen sulfate ion can further dissociate to give hydrogen ion. Okay, so that's why we call it an acid salt. Okay, so take a look at the common acid that we have learned before. Okay, so the first 4 examples, they are monobasic acid. So remember, for ethanoic acid, only the last hydrogen is ionizable. Okay, so it's monobasic. So for monobasic acid, we would not be able to form any acid salt. And let's work out the product from each of the reaction. When hydrochloric acid reacts with sodium hydroxide, we have sodium chloride as the normal salt product. And for nitric acid with sodium hydroxide, we have sodium nitrate formed. And for the third example, we have the nitrous acid. When nitrous acid reacts with sodium hydroxide, it should form sodium nitrite. Okay? And for the ethanoic acid with sodium hydroxide, we will form this compound. So again, the ionizable hydrogen ion will be replaced by the metal ion. So how to name this compound, we're going to learn in later units, so don't worry about it now. And then we move on to the dibasic example. So for the next 3 examples, they are dibasic acid. Okay, so for the first example, we have sulfuric acid. Acid salt is formed when only one of the hydrogen ion is replaced by sodium ion. So the acid salt should be sodium hydrogen sulfate. Okay, and then the normal salt would be sodium sulfate. Then next example, we have sulfurous acid. Again, if one of the hydrogen is replaced by sodium, then we form the acid salt. Okay, and the normal salt will be formed when both of the ionizable hydrogen are replaced by sodium. So the product should be sodium sulfide. Next one, we have carbonic acid react with sodium hydroxide. If we only replace one of the ionizable hydrogen, then we have sodium hydrogen carbonate. If we further replace the ionizable hydrogen with sodium, then we have sodium carbonate. And the last example we have here is phosphoric acid, which is tribasic. So it should form two kinds of acid salt. First, we can replace one of the ionizable hydrogen with sodium, so it will form this compound. So this compound is called sodium dihydrogen phosphate. Okay, and then we can further replace one of the ionizable hydrogen with another sodium, and then it will form this compound. Okay, so it's called sodium hydrogen phosphate. And then if we further replace the last ionizable hydrogen, then we should form sodium phosphate.